Let's look at another example just like the one we did before. Find the particular solution to the differential equation y double prime plus 2y prime plus 2y is equal to 0, given that the value of y when x is equal to 0, which is 0, and the value of y prime when x is equal to 0, which is 1. So once again, we are looking for particular solution. In order to find out what is a particular solution, we have to find out what is the general solution first. And in order to do that, we'll always start with the characteristic equation. So for this one, the characteristic equation is going to be lambda squared plus 2 lambda plus 2 is equal to 0. Let's solve the value for lambda. This is a quadratic equation. Once again, we just use the formula. So negative b, in this case, negative 2, plus or minus root b squared minus 4ac. B squared is 4, minus 4 times 1 times 2, which is 8, divided by 2a. So I have negative 2 plus or minus root negative 4 over 2. Well, you see a negative value here, so I hope this can remind you that we are actually dealing with case 3, complex roots, because b squared minus 4ac is less than 0. So we need to find out the value of lambda in the form of alpha plus or minus beta j form. Okay, let's move on. So this one is, now I'm going to separate these two parts. Negative 2 divided by 2 give me negative 1, plus or minus root negative 4 over 2. And I'm going to write this part in the form of j, which is root 4 times root negative 1, which is j over 2. And root 4 is just 2, so 2 divided by 2 gives me 1. So in the end, I have found the values for lambda, which is negative 1 plus or minus j. So alpha value apparently is negative 1 and beta value is 1. Then we can sub this result into case 3 and write down the general solution. So the general solution is y equal to e to the power of alpha times x, which is negative x, times a cosine beta x, which is cosine x, plus b sine beta x. Okay, x again. So this will be the general solution for this differential equation with a and b constants. So what's our next goal? Our next goal is to solve the values for a and b according to this and this condition. So let's use the first condition. Y of 0 is equal to, let's start from here. So e to the power negative 0, a cosine 0 plus b sine of 0. Well, apparently this term will give us 1, and a times cosine 0 will give us a, while b times sine of 0 will give us 0, because sine of 0 is always 0. So what is this value? Look at here, it should be 0. So well, that's good. The value of a is equal to 0. Then I can simplify the general solution a little bit. It becomes e to the power negative x, b sine x, because a is 0. And we're going to use the next condition, which is a value for y prime of 0. And you see the reason why I'm simplifying the general solution here. Once I sub in the value for a, the function or the solution itself becomes a little bit simplified. So it's easier for me to find y prime. Okay, b is a constant, so let me take it out. So it's b e to the power negative x sine x primed. Now we're going to use product rule. So I have two terms, u and v. When we look for the derivative of a product, we have u prime v So this will be u prime v plus uv prime. So e to the power negative x times cosine x. This will be y prime. So what is y prime of 0? We sub in the value of x to be 0. So it's b times, now this term has a sign of 0, which is going to be 0. So this whole term is gone. The next term, e to the power of 0 times cosine of 0 will give us, let me write it down first, 1. So it's just b. And the value is equal to 1 according to the given condition. Let's go back to the question to double check. Yes, it's equal to 1. So by now we have found the values for both a and b. And we can write down the particular solution now. The particular solution is y is equal to e to the power negative x times sine of x. And we're done.